Hell.
Mastering Chemical Nomenclature in Medicinal Chemistry. Hey everyone! Welcome back to our channel. Today, we're tackling a fundamental topic in medicinal chemistry, chemical nomenclature. This is crucial because correctly naming chemical compounds is essential for clear communication in science. Let's dive in. Chemical nomenclature might seem intimidating at first, but trust me, it's just like learning a new language. And once you get the hang of it, everything will start to make sense. So, let's break it down together. First off, let's talk about the basics. Chemical nomenclature is the system used to name chemical substances. The International Union of Pure and Applied Chemistry, IUPAC, developed the rules for naming compounds to ensure consistency worldwide. Let's start with alkanes. Alkanes are the simplest hydrocarbons with single bonds between carbon atoms. To name an alkane, you need to identify the longest continuous chain of carbon atoms. For example, if we have a 7-carbon chain, it's called heptane. Simple, right? Here are some common prefixes and suffixes you'll need to memorize. Meth, 1 carbon, eth, 2 carbons, prop, 3 carbons, but, 4 carbons, pent, 5 carbons, hex, 6 carbons, hept, 7 carbons, October, 8 carbons, non, 9 carbons, dec, 10 carbons, and don't forget the suffix -ane for alkanes. Next up, we have alkenes, which contain at least one double bond between carbon atoms. When naming alkenes, you not only need the longest chain but also the location of the double bond. For instance, but 1-ene has a double bond starting at the first carbon. Alkynes are similar but contain a triple bond. The naming follows the same logic as alkenes but with the suffix -ine. For example, but 2-ine indicates a triple bond at the second carbon. Cyclic compounds are another important category. When carbon atoms form a ring, the prefix cyclo is added before the name of the alkane, alkene, or alkyne. For example, cyclohexane is a 6-carbon ring with single bonds. Functional groups are key to medicinal chemistry. Let's go over some common ones. Hydroxyl group, OH found in alcohols. Example, ethanol, C2H5OH. Carbonyl group, C=O found in aldehydes and ketones. Example, propanol, C3H6O, and acetone, C3H6O. Carboxyl group, COOH found in carboxylic acids. Example, acetic acid, C2H4O2. Amino group, NH2 found in amines. Example, methylamine, CH5N. Combining these functional groups with hydrocarbon chains follows specific rules. For example, 2-butanol indicates a 4-carbon chain with an OH group on the second carbon. Similarly, for chlorobutanoic acid means a 4-carbon chain with a COOH group and a chlorine atom on the fourth carbon. Remember, there are exceptions in special cases in chemical nomenclature. For instance, benzene rings and their derivatives have unique names like toluene, methylbenzene, and aniline, aminobenzene. So, let's recap. Memorize common prefixes and suffixes. Identify the longest carbon chain. Determine the positions of double and triple bonds. Recognize and name functional groups. Combine these elements following IUPAC rules. Mastering chemical nomenclature is essential for anyone in the field of medicinal chemistry. It ensures clear communication and understanding across the scientific community. Keep practicing, and soon you'll be naming complex compounds with ease. Thanks for joining us today. If you found this video helpful, give it a thumbs up, subscribe for more content, and check out our other videos on medicinal chemistry. Happy studying, and see you next time. Thanks for watching, and I'll see you in the next video.
Pharmapal.